That's a TCP fast reducement, and we'll go over that as well. Okay.
So in this case, this is a buffer.
We don't know. We don't know in this case. So the way that I'm drawing right here, it assumes there is no buffer, because I'm acknowledging over here. So we decided that the acknowledgement was going to be, I'm running out of room here, but we assume the acknowledgement here is going to be 600, right? 600. If it's unbuffered, then the ACK is going to be 600, right? Now, what would happen if it was buffered? So if it was buffered, it means that the receiver would have saved those two out-of-order packets, right? So, and if you save the two out-of-order packets, then once this last packet arrives, it's going to fill in the gap, right? And then the receiver is going to have everything up to 2000, right? Makes sense? So maybe I should label 26 unbuffered, and 2000 buffered.
So from here, it just sends that whole sequence again.
Pardon?
If it's unbuffered, it just sends the whole sequence again.
If it's unbuffered, one by one, yeah. Basically, what's going to happen is once the timer expires and this packet is transmitted, right, and the sender gets an ACK for this packet, he will stop the timer and then time the next packet, right? And then eventually the timer for that packet will expire and the sender will resend that one, and so on and so forth.
So if it's unbuffered, after the receiver sends the acknowledge of 600, and then the second packet is sent in.
So if it's unbuffered, right, there is no acknowledgement of 600 right here, because the boot packet never makes it, right? And the packet never makes it, there is no acknowledgement.
I mean after the...
Oh, the acknowledgement of the retransmission, right? Yeah.
And then retransmission the other two packets.
Exactly, yeah. One by one though. Okay, so once he gets an F of 600, he says, cool, the receiver got this one, now I'm going to be timing this packet, and eventually the timing of this one is going to expire, and he will transmit that packet, etc. Assuming that, we're dealing with an unbuffered case. Because if the case was buffered, right, and I get an ACK of 2000, well, I'm done, right? Because ACKs are cumulative, right? Right?
So, I have a question. So let's just say the second sequence, the second 600 sequence is just got missing, and then the receiver receives the sequence of 1200. So then because there's one packet in the middle that's missing, does it still start over a sequence of 100?
So if there's a packet in the middle that is missing, right?
Yeah.
So if there's a packet in the middle that is missing, so like say this one, right? What's going to happen is when this packet arrives, right, it'll send an ACK of 600, right? And once the sender gets an ACK of 600, it'll shift the timer down and then time the next packet, right? Maybe we can draw this whole thing out just to make it a bit more clear. So now we're dealing with this scenario, right? So you're trying to say that, let's say our initial sequence number was 100, right? So init equals 100. So I send the first packet, right? Whose sequence number is equal to 100, and its size, and the size is equal to 500, right? And then I'm sending a sequence number of 100 plus 500, 600. And the size, I think, of this one was it 600 too? 600, yeah. 600. And then the sequence number of this one will be 6 plus 6, which will be 12,000. And the size will be, what was that one? 800. 800, okay? So basically you're saying that the second packet is going to be lost now, right? Okay, so the second packet is going to be lost. Okay, so he's dead, okay? So, he's dead, okay? So he's dead, okay? So, let's analyze this situation now. So basically, I'm cool with first packet, right? You know, so I get the first packet, I'll use black for x. So, and the x should be here, equal to, well, x is equal to the sequence number, right? Plus the size, 500 equals 600, right? Everything's good here. Now, second packet, no act, right? Because the packet never arrives, right? Oh, and by the way, initially the timer was timing this packet, right? Now, once he gets this act, now the timer is timing this packet, right? You know, that's supposed to be a timer. Okay, make sense? The timer is now timing the second earliest unacknowledged packet. In the meantime, the receiver gets the third packet, right? Now, what is he expecting? He's expecting sequence number 100, right? He's getting 12,000, right? He's going to be mad. He's going to say, what? This crap again? I thought we were done with this. He says, I'm expecting 100, right? And you're giving me 12,000. Please don't be an idiot and give me what? 600, right? And actually, I said he was expecting 100. Actually, he was expecting 600, right? My apologies for the confusion. I was still looking at that. So he will give an act of 600, right?
Yeah, I thought that would be an act of 2000.
Let's say, just make sure I get this right. He's getting. Oh no, that's right. He's expecting a 600, right?
Yeah.
He's expecting 600, and the reason he's expecting a sequence of 600 because he got this first one, right? And its sequence number was 100, and it contained 500 bytes of data. So the next sequence number should be 600. In fact, that was the sequence number of the missing packet, right? So he's saying that I want this, okay? And you're giving me that, right? Make sense? So he will send an act of 600.
Isn't it 1200?
1200. No, because 1200 would be the act of the lost packet, right? Yeah, it'll be the act of the lost packet, right? Because remember, the receiver does not know this happened, okay? He doesn't see the lost packet. The lost packet has never arrived. So all he got was the first packet, which had a sequence of 100 and contained 500 bytes of data, right? So he has rightfully acknowledged it, saying, you know, please give me the next packet, which is 600, right? Now, because the second packet got lost, the sender is now sending the third packet. The sender doesn't know this packet was lost yet. So he sends the third packet, right? That has a sequence number of 12,000. The receiver gets it. He's expecting a 600, right? But he's getting a 12,000, right? So he's going to set the sender straight by saying, nope, I want a 600, right? Make sense? And what's going to happen eventually? The timer will time out, right? So, you know, tick tock, tick tock, tick tock. Let's say it times out right here. And the sender is going to resend, right? Resend the packet whose sequence number is 600 and whose size is also 600, right? So he resends that packet. Now, and what's going to happen once the receiver gets this packet? He will say, good boy, right? And now send an ACK of sequence number, right? Plus size will be equal to 1200, right? Make sense? Are you good, Shelley?
Yeah.
Yeah. So, do you see why this ACK should be 600 and not 12,000, right? Because the receiver doesn't know anything about, you know, this packet. All he knows is that this packet is supposed to have a sequence number of 600, okay? Because he has gotten the first one, so he knows the next sequence number should be 600. But he knows nothing else about this packet. He doesn't know, for example, the packet size. Why? Why? Because, well, the packet was lost, right? I cannot know about the characteristics of the lost packets. Yep.
This is unbuffered.
This is unbuffered, yeah. So if it's unbuffered, it'll be 1200. Unbuffered. Now, if this was buffered, let's take a look at a buffer case, because that's always relevant. In case of a buffer case, how would things look? Well, so first I get a sequence number of 100, right? And its size is 500. So what do I know? I get everything from 100, right? All the way up to what? 599, right? 599, right? Looks good, right? So, and then that packet gets lost and I get this sequence number. Now, I'm not going to be throwing it away like I did in the first case, right? In the first case, I got it's out of order. Give me the right one, and I'm tossing the wrong sequence number away. Okay? Now, I'm going to save that packet. So, what happens when I get a sequence number of 12,000? Well, I know that I have a gap over here, right? So, I get a gap that stretches from 600, right? I got a gap here that stretches from 600, all the way up to what? To 1,000, to what? 1, yeah, 1999, right? Make sense? I get a gap over here, okay? One, yeah, okay. And I'm typing. Because that was a 12 count. So let's see, so we got 1, right? That should be 2,000, and 2,000 should be 1. Yeah, actually, I think this was right. Because we got 199, no, 9. 12. We got 12,000 over here, right? 1,200, sorry, yeah. I think I read the right thing, it just says it. Right?
Wait, it will be like, would it be like 1200 minus 1?
Pardon me?
Would it be 1200 minus 1?
1,200 minus, no, because we got a size over here, right? Oh, I see, yes, you're right, I'm sorry. Like also does tell on you eventually. So, yeah, you're right. So, we got a gap starting from 600, right? Going all the way up to 1, yep. So what comes before 1,200? 1 before 1,200. 1, right? 1, 9, 9, right? Right? So, we have a gap, right? Now, we have a gap. So, how does this gap eventually become filled? And by the way, we got everything else after that, right? We got everything else after that, right? So, and what's going to happen once I get the second packet? This retransmission right there. This gap is going to be filled, right? The gap is going to be filled, and I send an ACK of what? Just like we have right here, 2,000, right? So I'll send an ACK of 2,000. ACK of 2,000. Wow. My apologies, guys. Lack of sleep is telling me. Are we good? Right? Okay. Are we Shelley? Better?
Better, yeah.
Okay. Which part is still unclear?
So does it still go to like the the sequence? So does the buffer does buffer go through the same sequence as the diagram on the right?
does the buffer go through the same sequence as the one on the right, right?
Yeah,
So
as unbuffered.
basically, the only difference will be is this last part, this last stack. In the buffer case, that X is going to be equal to 2000. Because basically, remember, X are cumulative, right? So, and if he was buffering, once the get filler packet comes in, right? The sender knows he got everything up to 2000, right? Well, up to 1999 actually. Okay?
But it doesn't, but it doesn't have up to, so, but then the missing data is from 600 to 1199. But
Right.
it does have everything
Which was
after
filled by
1199.
the retransmitted packet. And that's the gap that this retransmission fills.
Okay,
We had a gap, right? Stretching from 600, right, to 199, and then this packet, the retransmission of this packet has filled this gap, right? It has filled this gap.
right,
Yeah. Yeah. Makes sense?
yeah.
Yeah. Right. So really, buffered and unbuffered cases will be identical until this last step, right? Because X are cumulative, right? And once the gap is filled, I will send a cumulative back for, well, basically, the whole thing, right? So basically, I'll say the next sequence number that I expect from you is 2000, right? The one that is right there. Make sense? Yeah? Are we good? Are you sure? Just making sure. Yeah. Right. Yeah.
So in the buffer case, after it sends the missing packet,
Mhm.
the act is the most is the last acknowledgement,
Right. Buffer. Yeah.
and in the unbuffered case, it just displays everything else.
Mm-hmm.
And
Because what happened in the unbuffered case, right? This packet was out of order, right? So it was thrown away. So when this packet comes in, right? So basically there is no this part, right? Because this part was thrown away because it arrived out of order. So in this case, when the retransmitted packet comes in, the sender says, okay, this gap is now filled, right? But the receiver says this gap is now filled, and eventually the sender's timer for this for the third packet, right? Because once the sender gets an acknowledgement for this packet, right, he will shift the timer down to the last packet, right? So the timer will expire, and he's going to resend the third packet, and then eventually the whole thing will be acknowledged. Okay? So basically, more work for the sender. Make sense? Right? Very good. Yeah. All right. So, oops. Okay. And what about if so part B says the first segment arrives and the rest are lost? How would this diagram look then? So that should be pretty simple, right? So first arrives and the rest are lost. So well, actually, what we can do is probably just modify this diagram. That's okay. That's right. So I'm sending the first packet. It makes it okay. So sequence of 100, size of 500. Okay, it makes it just fine. Second packet, sequence of 600, size of also 600, but it's lost. Third packet, sequence of 1200, and size of 800. Also plus, right? So, whoa. Okay, I'm going to get rid of here. So, what's going to happen in this case? He gets this one, right? He gets the first packet, everything's fine, he sends an ACK, right? And the ACK will be sequence plus size equals to 600, right? Well, which packet was the timer originally timing? This one, right? But once he got this ACK, now he's timing this one, right? So basically, let's say this is the timer that is timing this packet. So tick tock, tick tock, tick tock, tick tock, and eventually what's going to happen? Timeout, right? Bam. Timeout, right? And once the timeout happens, what will he do? Reset. Which packet is he going to reset? This one and this packet only, right? It's not like go back in. So he's going to reset a sequence number of 600 and the size of 600, right? And what's going to happen next? Let's say the receiver gets it. He's going to send an ACK, right? And his ACK is going to be sequence plus the size, right? 1200, right? And if the receiver gets this one successfully, the timer is now shifted down to the other packet, right? So it's not going to be shifted down here. Okay? And eventually what's going to happen? It will time out, right? So, and once the timer times out, somewhere later on, the last packet will get retransmitted, right? So can you see that, or is?
Does it time out at the sequence 600 or does it time out at the ACK of 1200?
For which one?
So the last packet
Let's-
doesn't arrive, then there's a timer on it. Does it time out at like the bottom? Like, does it time out there where you're pointing at, or does it time
So,
out like?
It's going to time out. It'll time out at the time of retransmission, right here.
Okay.
Yeah. And also, it's kind of hard to show on the board, but basically, this timer, it gets moved down to the third packet right after getting the ACK for the, for this packet. That was a big mistake, right here. Right? Mm-hmm. But it's timing this packet. So I was just kind of trying to show it on the board. It's kind of hard to show on the board. But yeah. But that's basically, the time slice when that time runs. Make sense? Right? Yeah. Very good? So, yeah, basically that's the idea. And then, all segments arrive successfully. However, the X for the first and third segments are lost. When the timer expires, what segment will be retransmitted? So, once again, we have this kind of a situation. So, everything is going to arrive fine in this case. Okay, so all of the packets arrive just fine, but we'll have some lost X. So we're being told that the first and third X are going to be lost. So X is equal to 600. X is equal to 1200, right? And N is equal to 2000. Now, we're being told that this ACK is going to be lost. This ACK is going to be fine. And that ACK is going to be also lost, right? So, let's see what's going to happen. Well, first ACK is lost, so, well, too bad. What about the second ACK? It arrived just fine, right? Now, here is the thing. In TCP, the ACKs are cumulative, right? So, what happens once the receiver, once the sender gets the SEC? This SEC acknowledges not only this packet, but also the previous one, right? So now, basically, what does the sender know? The receiver has successfully got everything from 100 to what? To 599, right? To 599, right? Make sense? Yeah. So, and actually, let's see. Well, actually, no, because he's got everything up to. Yeah, because and you know why? Because the packet contains 600 bytes of data, right? So basically, once again, we're talking about this one, right? 1199. So we've got everything to 1199, right? Now, what about and what happens to our timers? Well, the timer was initially timing this packet, right? But once he got this ECK, he knows that this guy and this guy were received, right? So, now, which packet is he going to be timing next? Well, the next unacknowledged packet, right? Which is packet number 3, right? Make sense? So, and what's going to happen? So, like, the timer is ticking, and then expires, right? And which packet are we going to retransmit? Well, the packet with which the timer is associated with, right? Which is the last packet, right? So, I'm going to resend. Which packet am I resending? The last one, right? So I'm resending a sequence number of 1200 and the size of 800 and what am I going to get? 2000. I forgot a zero there. 2000. All right? Make sense? Now, in this case, will buffered versus unbuffered matter? No, right? Because why? Because we're dealing basically with the last packet that the sender thinks is lost, right? So really buffered or unbuffered, in this case, it will not make a difference.
So,
Yep.
so even though the sender doesn't receive an ACK, it just kind of assumes that the receiver already has the first packet.
That's right. Because ACKs are cumulative, right? Because this ACK, it acknowledges not only this packet, but also everything that came before it. Mm-hmm. Yeah. Mm-hmm. The power of a cumulative ACK. Okay? So basically, that's the idea right there. Okay? Now, suppose the sender sends 4 additional 500 byte segments right after sending the first 3 segments in part A. Assuming all segments except the second segment in part A arrived and were acknowledged in order in which they were sent, the X, what will be the X and how will the sender react to each received X? Basically what we're being told that, let's say, this happened and it happened successfully, and let's say that the sender wants to send more stuff now, okay? So how will things look? So he sends 4 additional back-to-back packets. So how will things look? What should be the sequence numbers of those segments? So he's going to send 4. 1, 2, 3, 4. Okay? Space them out. Like that. So now, what would be the sequence number here? Well, the sequence number of the first one should be 2000, right? Right? Because that's the next expected sequence number. And the size, and I'm going to need size, for neatness, because the size isn't going to be the same. And we know that the size of each segment is 500. So then, he's going to send the next one, and what's going to be the sequence of this one? Well, it'll be the sequence number of the previous one plus 500, right? So it'll be 2,500, right? Make sense? And what about the next packet? Should be 3,000, right? previous sequence number plus the size of the previous segments equals 3,000. And it says 4, so I need one more arrow. So it'll be 3,005, 500. Make sense? Right? Now, and what will the X look like? So the receiver will send back X. So X1, X2, and X3. So the X in this one will be it'll be equal to the previous sequence number plus the size. It'll be 250, right? Then the next stack is going to be equal to the sequence number plus size. It'll be 3,000. Alright, and then the sequence number of the next one is going to be, it'll be what? It should be equal to? The previous one's supposed to wait, we got 200, and that's correct. And then this one should be 300. I'm getting ahead of myself. And then this one should be 305,000. And the last one should be? Okay, that'll do that. It'll be what? 4? It'll be 4,000, right? Maybe I can make it a little bit but here. That's what it's referring to. Right? Make sense? I'm really running out of room here. Right? So, alright. Okay. The next problem asks us about an RWD. Let's take a look at a few more problems just to really solidify our understanding. Sounds good? Let's look at the supplemental problems, which we did in class. Maybe you'll review a few of those. How does that sound? Good? Yeah, alright. So, let's see. And let's try, a few easy ones and then a few ones that are a bit more challenging. So, oh yeah. Yeah. We should sue the Coca-Cola company. Did the Bible say, shake well before using? Yeah. Let's do it. Yeah. All right. So that's basically the idea right here. Oh, what is this? Oh, thank you. Oh, thank you so much. Oh, I appreciate that. Aw. Oh, thank you. All right. I give you a hug.
This is Rodrigo.
Oh, thank you, Rodrigo. I want to give you a hug.
Shy.
Oh, thank you. Thank you. I really appreciate that. Thank you.
You give me pizza, I give you that.
Oh, thank you. Thank you. I'll hug you just for camera. Right? Yeah. So, whatever. Oh, what a nice guy. Is this like a Mother's Day gift? Yeah. Yeah. Thank you. Yeah. Looks good too.
After operating systems, like we kind of our mother, so.
Oh, thank you. Thank you. Yeah. Oh, thank you. Yeah, I try my best to yours, you guys. Yeah. Thank you. I'm just so touched. Oh. Yeah. So. All right. So yeah, let's try an easy problem first. So in this easy problem, we have initial sequence number 100, right? Now at this point, it's probably very easy, right? So how are things going to look like from here? So the sequence number is going to be the first one, 100, right? Second, oh, my sequence number is And then the next one is 200, right? 100 plus size equals 200. Next one, it'll be equal to 400, right? Easy, right? Now, and what about our x? And you know what? Just to make things a bit less confusing, I'm going to make it green. Now, our x are green, okay? And I can just copy by virtue of copy and paste. I can make things work because we are problem solvers, and that's what we do. We fear nothing. All right? So, and what's going to be the x in this case? 200, right? So x equals 200. And the next x? 400. And the next? Should be 700. Oh, 700. I got arrows going all over the place. 700, right? Makes sense, right? So, at this point, you know, those problems should be pretty easy. I gotta try that, right? So those problems should be pretty easy. Alright, let's give it a taste.
You gotta mix it a little.
I think something like 7, maybe.
Ah, it's sort of foamy, interesting.
But,
You wanna get a little? There we go. Yeah. Alright. Now people who are studying for the exam, you know, they get to watch a few minutes of this. So.
yeah,
Can never go wrong with Jasmine.
yeah.
It is a Jasmine.
Yeah.
Thank you.
You made me pick.
What's that?
I said he made me pick.
Oh, I see. It's like a revenge.
Took hours of deliberation. I was like, is he a Jasmine person? Is he not?
Oh, thank you, yeah. So, no, it's good. It's
I'm
good.
glad I got it.
Oh, thank you, yeah. In fact, you know, gotta use a bit of stimulus now. So, yeah, so, and what about the second case? In the second case, we got a lost packet, right? Right? And because the packet is lost, what's happening? Now, sequence numbers will be the same, right? Sequence numbers are going to be the same here and there, right? In fact, this case is basically copy and paste of the other case. The only difference is X are, we have a missing first packet, right? So let's kind of, you know, copy the sequence numbers there just so we're not, you know, called lazy by the future generations who happen to be watching this. You know, it's all about the future. And also, when people watch my YouTube videos, you know, I'm trying to compete with so many cats on YouTube. And as you can imagine, that's a very challenging and sometimes, you know, seems like it's a seemingly hopeless task, right? So, now, and what's going to happen? So the first packet goes missing, right? So, what is he expecting? 100, right? What is he getting? 200, right? What is he going to be? Angry. And what is he going to say? You're giving me you're giving me 200, right? When you should be giving me a 100, right? 100. Idiom. Yeah, idiom. Well, packets can also get corrupted, not just lost, right? Makes sense, right? So, alright. So, here, like that. Just so it looks nicer, right? So, in my photography class, somebody sent me feedback saying, I'm tired of listening to your rants, you know, you stupid Russian. You know, and I got offended that, you know, I replied, I'm actually stupid Ukrainian. Get those things right, okay? So, yeah. Hey, if you're going to be xenophobic, you might as well get it right, right? So, yeah, so I hope I said it straight, okay? So, now keep supposed to be the right way. So, okay, so, well, actually, I don't know, he hasn't sent anything back yet, so, but I'm looking forward to it. So now, and what's going to happen right here? Well, he gets a second packet also out of order, right? He's still expecting 100, but now he's getting 400, right? Makes sense, right? So, yeah, you know, lay off the dough. Yeah. Right? Makes sense, right? Yep. Are we good? All right. So those are these kinds of problems, you know, easy points on the exams. paste to the previous one, right? So once again, let us let me clone the other two. Okay, maybe yeah, for clown. Okay. So we have 100, right? 100 followed by 200 followed by what? 200 plus 200 is 400, right? We got 400. All right. So the first one arrives fine, right? So the act should be 200, right? Act equals 200, right? And then we got this one, right? Which is going to be 400. Oh, we got a problem though, right? The stack is lost, right? Now, and what's going to be the act to the last packet? Same, right? Should be, well, 400 plus 300 equals 700, right? Now, here's the thing. So, like, the question is, how will the receiver, how will the sender react? Well, it depends, right? Buffered or unbuffered, right? Let's take a look at the unbuffered case. So, in the unbuffered case, he's going to, well, actually, in this case, it doesn't matter, right? In this case, it doesn't matter, because buffering only affects lost packets, right? In this case, we don't have lost packets, we just have a lost stack, right? So, it seems that the second act has, well, perished. So, but, are we going to miss it much? Will the sender miss it much? No, right? Because he got the last one, right? And that tells him that he got everything, right? Up until and including the last packet, right? Because once again, X are cumulative. The X, the act of this last packet, it's acknowledging not only this packet, but also all packets that came before, right? Make sense? Right? Now, what about the brother of this problem that is right next to it? Is there going to be any difference?
No,
No, right? Because why?
accumulated.
The last act has arrived and the acts are accumulated, right? Make sense? Right? Alright. So, looking good here. Oh yes, I think everybody enjoys those problems, no? Mm. Mm. We'll live with this, right? So, ow, right? This looks very painful, no? Yeah. So nothing is lost, right? Well, except Pulp Maker, right? Right? Yeah. Nothing is lost in this case, but things are jumbled up, right? And hey, Network Core can do those things, right? It can choose to reorder packets whenever it feels like it. So what do we do about this? Yes, we could cry, that's true, but let's see. Well, first of all, before we panic, let's figure out the sequence numbers, right? Because sequence numbers won't be affected. So the initial sequence number should be